guys. I'm David from Formlabs. We're a 3D printer company, and we are headquartered in Boston. And I recently moved out here to the West Coast, the Bay Area, to start up a new office. So we're currently based out of Sunnyvale, and yeah, I have some slides to show you guys. For you guys who don't know, Formlabs started off as a Kickstarter campaign back in 2012, and at the time it broke the record for most money raised. It was at $3 million, and since then we've grown quite a bit. We're now over 300 people. We have 3 offices, and we have like hundreds of engineers that are working both on materials development as well as on new generation like printers. So right now what we have on the market is the Form 2 stereolithography printer that a lot of engineers, product designers use. And then we also have the Fuse 1, which is coming up next year, and that one is a nylon printer. So I brought like sample prints. You guys can check it out later on that table. So where do we fit in? There's the low cost, easy to use like FDM printers on one side of the spectrum, and then you got like the large industrial like high accuracy printers. So the Formlabs printer fits like right in the middle there. Where it's high precision but at an affordable cost. So we're currently the #1 selling desktop 3D printer in the world. And so like the main 3 markets that we typically address are like you guys, like hardware engineers that do a lot of product design and are in manufacturing. We also work with a lot of higher education universities. And then the biggest growing segment right now is the dental market. So like when you think about aligners, retainers, you can print that off our printer for about a few dollars. So dentists are like flocking over to this because they can make like huge profit margins off of their patients. And yeah, we have a whole bunch of different materials for different applications for varying industries. And then there's also like software that's included with the printer. So like this is just like giving you a general overview of like some of the companies that use our printer. Like they'll have the Form 2 printer on like every engineer's desk at some of these firms. So this is my take on where manufacturing is headed. It's more specifically where additive manufacturing is headed. So there's like these 4 steps where there's a adoption curve of additive manufacturing, and I'll go into a little more detail in terms of like what each of these steps mean for me. The first step is having limited access to 3D printing. So for example, this company called Coalesce, they were doing a product design of this, I think it's called a breathometer or something to see the volume of your lungs, like the lung capacity. And they typically outsource this type of like prototyping work before they go into mass production. Typically, it takes about 1 to 2 weeks turnaround. And then there's a cost of about like $250 per part. So this is like when companies have limited access to 3D printing. And then the next step in terms of this like adoption curve is actually having access to 3D printing. So meaning, the firm or the design studio or the department gets a whole bunch of 3D printers to allow their engineers to iterate faster in-house. And so, for example, in this case, it takes about 8 hours for one of those prints to be done in-house at about $11 per part. So there's quite a bit of savings that you can achieve by bringing in additive manufacturing. And then along this adoption curve, like the next two steps are sort of the what's going to happen in the near future, and we're already starting to see that with some of our clients. So for example, Uvera, they'll like scan your ear, and then they'll print out custom ear molds for your earphones. And then ultimately, it's talking about additive manufacturing at scale. I think that's the hardest thing right now to achieve is like, you want to do mass customization, but how do you do it for everybody? And so we're working on that as well. So we have a partnership with New Balance where they'll scan your feet and then they'll print out the custom midsole with our printers. And this is at scale, like we're talking about tens and thousands of units. And then the other part too where I see additive manufacturing headed is making end-use parts affordable as well. So sort of what I told you about the SLA printer, the Form 2, trying to hit that sweet spot with this new nylon printer. So typically these type of nylon printers are about in the $200,000 to $250,000 range. And now companies can get this printer for about $20,000. And you're able to really pack in everything. The engineers can do a lot of functional prototypes, but as well as use these, let's say for example, these bike pedals for end use. So there's an engineer who actually printed out these bike pedals at Formlabs, and he's been using it for the past 6 months. And yeah, so just a quick general summary, like where we are now in terms of this like units produced versus cost for additive manufacturing is, I talked about dental, where you can make aligners, but this is like only like a few at a time. And then where we're headed is hopefully mass customization, but at scale and at an affordable cost. That's where we're trying to head at Formlabs. There you go.
Thank you. Yeah, as Anand said, I'm Matt Wilson-Plasek. I'm a business development director at PolySpectra, and brief outline. I'll try to keep it pretty short, but I want to talk about like 30 seconds on my context, and then go into what PolySpectra is doing and why we're doing it, and then finally some kind of broader industry 3D printing. So my educational background has basically been all in aerospace engineering, and in grad school I took basically a space propulsion experiment from concept to working experiment with data, and in there was a lot of technical challenges that manufacturing played a big part in, whether it be, it was in a vacuum tank and there's like, really high currents, like hundreds of amps, and we got up to like 2,000 degrees C in one part of the experiment, and like there's plasma everywhere, so that makes everything entertaining. But it really got me thinking about kind of advanced manufacturing and what we can do on a broader scale, a broader sense to really bring things into the future. So a friend and I started an advanced manufacturing company for rapid tooling, specifically for metal casting. And one of the big fundamental problems we kept on running into was that 3D printing materials were not good enough. 3D printing in general was not good enough for what we did, even though we tried a bunch of different ways. Eventually we did workarounds and used machining and other stuff. But basically I'm at PolySpectra now, and to me it's really exciting because PolySpectra is actually trying to solve that problem. There's very few groups in the world right now that are attempting to do that. So PolySpectra is a company out of Berkeley. We're a startup currently out of Lawrence Berkeley lab in the hills up there. And basically, like right now, the choice we had at my manufacturing company was you either have the properties or you have something that looks and maybe fits well, but you can't have both. So on the property side, you have like FDM and SLS, where you get pretty okay properties, but the surface finish and the accuracy is lacking. And then you can go to SLA and maybe like a polyjet or a multi-jet of some sort, and you can get pretty good surface finish, especially for printing, where it's very close to injection molding in some cases, and you can get good accuracy, but the properties are terrible. They suck, and like you'll drop it on the ground and it breaks, or you leave it in a hot car or ship it and it droops from the heat. So I think there's like really a gap there where we can't just have everything that we want to have. We can't have 3D printing very easily right now that acts like our mass-produced parts. So PolySpectra is really trying to like solve that from the materials approach. And so right now, basically, part of our vision is to have materials. So we just soft launched our first material. So if you guys want to go to our website, check out some demo videos, you can upload an STL right now. We're doing parts as a service just to get some early feedback. And I think right now we're releasing our first material, but our vision is to have a specific material that you can 3D print and then have that match a production material. So you could have something that matches ABS in the critical aspects, which there's lots of materials that are ABS-like, but actually matching and not being 60% of the properties or something like that. So you don't have to worry about when you print something, does it actually match what you'll be producing? And so you could do it with ABS, you could do it with Delrin, glass filled nylon, any of these kind of materials where we actually have a material to match it. So I think one use case is that makes it really easy for product developers, hardware engineers to basically say, okay, we print this and we can trust that this will behave exactly like when we take it to production, which basically means you take all the risk out of tooling up, spending the tens of thousands of dollars or hundreds of thousands of dollars to go into injection molding tooling. So I think that's one really interesting use case, and then the mass customization is the other really interesting use case that we really haven't seen too much of, and there's different parts of the puzzle that I'll talk about briefly after this, but one of them is definitely materials. So you have to be able to have the real materials, the real properties in order to have the parts. You can't get around that. For us, that's really important, and I think for me personally, having lived that's really important. So I'm excited to be at PolySpectra, trying to solve that problem and create these use cases, both making people's current jobs easier, but also getting into kind of new models where people can sell parts locally. They can sell, they can create a toy, or they can create a low volume industrial product and just print parts, because it is like the final part. You don't need to injection mold if you're only making 100 of something. So I think that's that, and then the mass customization part of this are really exciting and where the industry is headed. In general, right now, I would say the good parts about 3D printing as a broader industry is that from all the people that I've talked to, product developers usually start with 3D printing, and then they move to other manufacturing processes to get better properties. So I think 3D printing is really easy to design for, especially if you're then trying to convert from kind of conceptual phase to CNC, and then maybe injection molding or some version of that. Maybe you're doing urethane casting in the middle. The 3D printing with that design freedom, it really allows you to not worry about manufacturing constraints, or it really lowers the minimum knowledge in order to actually make something. So, opening it up to more and more users, making product development easier for the people currently doing it. I think those are all really exciting things that 3D printing is really good at. Some of the bottlenecks, I would say, so I'm talking about kind of the end of the very right side of the slide where it's like, okay, the future. So for me, the mass customization or encroaching on what would typically be a injection molding volume. For me, the kind of three main bottlenecks, the first is manual labor. So this includes all sorts of things from kind of the semi-automated, so I know Formlabs and basically all the major 3D printing companies are coming out with semi-automated systems to help really take the labor out of it. That's really important because a big part of 3D printing, which is kind of the dark underbelly of printing, is the post-processing. Sometimes it can take a really long time to post-process stuff, and people always talk about the print time, but to actually get a part in your hands that you want to use can sometimes take a really long time, especially for nice parts. So the more we can automate that, the more the rest of the industry, we're not materials companies, can fix that problem. I think that's really great, and I think we should, the challenge should be automate stuff as much as possible, because that will get us to mass production, and that'll get us to mass customization as much as that's an important part of the puzzle. And then I guess the second thing I would say is basically quality or quality control of your parts. So I would personally split this up into two categories, one being kind of what I'll call the product development quality, and the second would be the aerospace quality. So the product development quality is kind of what I've talked about already, which is, okay, you have a part and it looks beautiful, and then you drop it on the way to the investor meeting and you're like, oh crap, I just cracked my part. So the kind of general engineering plastics that we're used to and that we expect when we design something, those should be in there, and that's part of what PolySpectra is trying to fix, as well as a few other companies. So that's one part of quality. The second part of quality, or second segment of it, is what I would say aerospace quality. So aerospace quality basically means that you never want it to fail. So if you're, whether you're flying on a commercial plane or you're sending up a spacecraft, you really just get one shot, and you want it to be as reliable as possible. So what that means is, when you're printing a part, to keep track of every little detail, all these parameters, so that if something does go wrong or ever happens to go wrong, that you can trace it all the way back and make sure that problem is fixed and never happens again. So I think, from my perspective, there are several companies and groups working on this specific problem, and so we're definitely not there right now. And I would say, in aerospace in general, they don't really trust 3D printing, but I think, we're making a lot of progress on that front, even if it's not really very public right now. And I think in the next 5 years, we'll see a big difference in what can be done with plastic printing and also metal printing. So those are kind of the quality bottlenecks right now that I think we're making a lot of progress on, but don't really, are a bottleneck right now. And the final thing is basically what I've already said, which is materials. And I guess the last thing I'll say about it is that materials are really a gating function. So if you make 3D printing way faster, way more efficient, if you get the quality up, it doesn't really matter if you can't get the properties. You can't get real parts, you can't get mass customization of final products going to customers unless you have the materials. So I think this is a really key part of it, and so that's why I'm excited that our first material is definitely by far the best SLA material out there, and pretty competitive with basically any other 3D printing material out there right now. So this is the first of many, and hopefully we'll have much improved that can match all these other engineering plastics that we know and love. So yeah, so I guess I'll stop there, and hopefully we can have more time for questions.
Thank you. Has anyone heard of Fictiv before? Okay, nice. Yeah, so Fictiv is an online manufacturing platform. We do additive manufacturing and subtractive, so we're 3D printing, CNC machining, urethane casting, sheet metal, some injection molding as well. We're based in San Francisco, startup there, but the nice thing, one of the things about us is we don't actually own any of our own machines and printers as well. So we work on a distributed model. So we have printers, machine shops that are all around the Bay Area. And we really believe that the people doing this, they have a lot more expertise in actually printing, and that it's, we should let them do the best work. And so with even with printing, there's we have a lot of printers there that they might work on really crappy machines, but they can produce some of the best PLA parts out there because they've been early adopters of it as well. And so as a newcomer to 3D printing, it can be quite hard to get used to the machines to actually start producing quality parts out of it. So we focused on accessibility really. So we feel that there isn't really much point owning a 3D printer or even a CNC machine or working directly with a CNC machine shop. It takes a lot of time, and it's a lot easier if you can just like upload your file to a platform. Then you can actually just pick whatever process you need. So we look at one of the things we ask is what do you want to do with this part? Are you looking for strength? Are you looking for look? And what sort of temperature resistance, and then trying to match you not with the process of 3D printing, but for the best process for your actual design as well. So when someone uploads a part, we'll do an instant quote, so you can see straight away how much it's going to be, and all the different materials, all the different processes, and then if you want to do CNC machining, we'll do a design for manufacturing check on that as well. So we'll actually be able to tell you, hey, if you're going to machine this, you're going to run into these issues. This part is going to cost more. And so to give users that feedback on the actual process before they actually have to go through that and actually make a purchase. So we do very fast turnaround. So if it's 3D printing in the Bay Area, we can do the same day. So order that morning, you'll have it in your hands that evening. For CNC machining, we can do 3 days. And so we're not constrained because of that network of machine shops. If you want to do 15, 20 parts, 15, 20 prints, and you can do that, and we can send that out to different machine shops and different printers and get that back to you within 24 hours or 3 days. And so we do all of the quality control in-house, check for all the tolerances in there. And so, we really feel that you shouldn't need to own these machines, that it's going to be a lot easier to actually just have a service that you can actually go and ask questions, talk to each human. And so if you have something special, like say you want to do like a special material that has certain properties, and then we can sort of do that customization there as well. So yeah, I guess for some of the things, the limitations of 3D printing we see is, definitely around lead times for mass manufacturing. So if someone, it's pretty cool that, you can do like 8 hours for a print, but, if you have 100 prints, then, that time it takes to actually print that is a huge amount. So, injection molding is there. It's been around for a very long time, and there's still a lot of opportunities there to actually reduce the costs and increase accessibility there. So we do a lot of urethane casting. So for 1 to 10 units, we look at 3D printing. For 10 to 50, we kind of look at CNC and urethane casting, because at the moment that's kind of the quickest process, and you don't have to do any post-processing on that as well. So a lot of 3D printing, there is a huge amount of post-processing that goes on, and so we take care of the post-processing for 3D printed parts, but for urethane casting, it's pretty much ready to go as well.
Thank you. So they're doing 10,000 parts. Each one is different.
Yeah.
Right. And this is the point, is that if you're going to do 10,000 identical parts, then injection molding makes sense, because although there's a setup cost, the cost for 10,000 parts is really cheap. But if you have to do 10,000 individual ones, it doesn't make sense, right? So the flip side of that is, will products become more customized? Would you really want to mass produce a product because the main choice is going to be on the basis of price? Or are you going to want to make it custom because that's going to drive the price? If you're going to drive custom, that would make you choose 3D printer choice over a mass-produced injection molding device. And that's why you see it in things like Invisalign or in dental and audiology and stuff.
Good. Is anybody aware of any new or up-and-coming 3D printer technology that may be significantly different from, FDM, SLA, SLS, or whatnot?
I mean, I'd definitely say there's definitely like research being done on new processes. I don't like there. So for example, there's kind of the extreme. So there's like extremely small 3D printing, like nanoscale. There's different types of metal printing going on, but none of those are like. I mean, those are probably 5 to 10 years out. I don't know if you're talking like right now or.
Well, I was just curious if there's something that I wasn't aware of that was, new or up and coming, because I haven't really kept up with the latest. What's going on.
I guess desktop metal, they just got a lot of funding. They're producing end parts for aerospace, but it does take 10 years, for this stuff to trickle down from the Boeings, the GEs, Formula One that are using this. So before it becomes something that's on the consumer or industrial level, like it's a couple of years down the line. I seen that Elon Musk did Reddit AMA there during the week, and he was asked about what's his applications of 3D printing, and is he using it in SpaceX? And it wasn't. It was still in the prototyping phase. Up there, they were using traditional machining methods for it as well. So
Well, I will say both SpaceX and Blue Origin do print lots of like actual engine parts out of metal, of course. But so it is used, but like for most stuff, definitely not.
When you say print, do you mean 3D print metal parts?
Yeah, I do.
What is, I mean, that's what it seems, but you just said that they weren't using it on the engines. I'm just confused. I don't know who to believe.
Well, so they are printing like part of the engines, but for most of the parts, they are using traditional manufacturing.
yeah, I mean it's not something that's
How
used
do
a
you
lot.
print metal? You just like super glue?
Yeah, so there's a bunch of different ways. So I would say like all of the new kind of printing coming out is mostly like greatly reducing the cost of printing that has existed in for the last 20 years. So for metal, it would be like some sort of laser sintering or laser melting, where you do a powder bed, a small layer at a time, and then you use a laser to melt it. Another way is to basically glue it, and then do a post-process where you cure it, and everything kind of syncs up together, and either sinters, some version of sintering. I think those are kind of maybe. Well, I guess it's probably 3 main categories. Another one's like just flat out welding, effectively, where you're having more of an FDM style, where you're putting out metal and then you're welding it in place.
What do you guys think is more further developed, the metal side or the plastic side? I've heard different opinions on this.
Yeah, that's a really good question. I think from my perspective, metals are a lot harder, like just in general of a technical problem, because there's something that is a big problem anytime you're going through a phase transition or from liquid to solid is the shrinkage, and metal has a way bigger temperature difference and a way bigger shrinkage due to the phase transition. So that part and not having your part warp as you're building it even and break, or just having kind of ridiculous internal stresses, those are really hard problems. And I think metal, in that sense, is, it takes a lot more work to get to kind of the same level where things are acceptable. And they're also used for higher stress things, more critical parts. So where plastic, you can be over here in the development stage, and it could be acceptable. You have to get quite a bit further with metal. So I assume plastics are in general ahead of metals in that way.
We get asked a lot to, can you 3D print metal for us? And we can sometimes get a quote, but it's so astronomical that it's like, hey, why aren't you CNC machining this? As you mentioned, good use case is engines. I heard of one. Yeah, some companies are using them because of the geometries that you can get, and you just can't get that. So you can't use that for plastic, and so there is a lot of weight saving stuff, heat dissipation as well that you can do. But I think, the use cases are so small that until it's like widely adopted, the development just is going to be quite limited to specific cases as well.
Those that are like skin safe and for applications like that. Because I know historically people were using SLA to go out and create like an eggshell mold and then put in silicone to get some kind of soft material that was FDA accepted for continuous skin contact. What's happening in that space?
Yeah, so Formlabs, we actually just came out with an FDA-approved material 2 weeks ago, and that one is where you can print out like a mouth guard directly off the printer, and it's rated like for indefinite use intraorally. We also have another material as well. It's called like Class 1 biocompatible material. So that one, it can only be in your mouth for about 24 hours, and dentists typically print out what they call surgical guides. So think of those as just like a jig or a fixture that they pop into your mouth. So those two types of materials, the Class 1 biocompatible one and the new one that just came out, which is a Class 2 biocompatible material, are also used in a lot of wearable companies because they are rated as skin safe.
Okay.
So Class 1 is 30 days on skin contact, and then the Class 2, I'm not as sure in terms of like if it's indefinite, similar to the intraoral rating, but I would assume it's a longer term use. So yeah, we do have wearable companies that are using our resins for that
What
specific.
kind of shore values do they have on that Class 1?
I don't have it off the top of my head, but it is quite rigid.
Oh, it's really good.
Yeah.
Okay.
You can check it out later. We can talk more about it. Yeah.
Yeah, no, that's cool to hear because that's very recent. Because I was at a medical conference earlier this year where their Carbon was there, and they were talking about trying to get one of their materials to be basically the first SLA resin or DLP resin that was approved. So this is great that a few companies now. So it's pretty limited.
Yeah, it's challenging, especially challenging if you want to create something that's soft, that's not going to sag while you're printing, but then
Yeah.
it's going to also have the properties that you want to pass the FDA requirements.
Yeah, so I think it's definitely a good spot.
That's been going.
So this is like somewhat related, or maybe a little bit unrelated, but you're talking about mass customization, and you're talking about like, how are you getting those measurements? Like you're using a 3D scanner, like what is that? How are you doing that?
Yeah, you use a 3D scanner.
Do you guys make that in-house, or do you have to go external for that?
Yeah, the 3D scanning part is, so I'll give you like the dental example. Like your dentist would, if they choose to do so, invest in a 3D scanner where they can scan your teeth. Yeah.
And then does that just like automatically translate like into some CAD that you guys just plug in, or?
Yeah, so the dental people, like the scanner companies, typically have a dental software that they use to design, let's say, your Invisalign treatment. And then that CAD software will generate files that can then be printed off the printer.
So if that's specific to like, so let's say I'm a dentist and then I'm like, oh, you know what, I want some more New Balance shoes, I'm gonna use this machine and scan my feet. Can it change that way or?
Okay, yeah, so the thing is like you can use like an intraoral scanner to, let's say, scan yourself and other body parts, but like I would say like there's scanners, like industry specific scanners, let's say, for their specific purpose. Yeah.
I think the new iPhone has a 3D scanner.
Really?
Yeah.
Not a very good one.
Not a very good one, but you know, it's getting a bit more mainstream as well.
Do you guys get requests from people scanning anything?
Yeah, usually the resolution's just not there, I think, yeah.
Yeah,
But even if you had good resolution, the main thing that's happening in situations like that is it's one thing that you capture the space that you want to mate with, but you're going to create something new that's going to do more than just mate. And there's a bunch of other CAD work, smoothing and reshaping that's going to go on, and all that's going to tend to be very application specific. So that's why the companies that sell the dental scanners will have a scanner, they'll have CAD for dental stuff, and if they were doing something for gloves, they would have CAD that would be different for gloves because fingers can move in ways that you can't.
Yeah, and just to continue on with that, like the process of going from, you scan and you get effectively a point cloud, and then to go back to a model that you can actually manipulate to design what you want, that's a lot of work and really crappy right now. So yeah, I think there are a couple Bay Area startups actually that are working on this, or at least for specific products, for specific use cases. But in general, it's not easy to go that direction. If you just want to say, hey, does this have the right measurements? That's a lot easier. But if you're actually trying to manipulate and design something off of it, then you need like application specific software, basically.
So when we're talking about mass customization, it seems like all the examples are sort of the around ergonomic type things, like things that interface with your body in some way. And I'm just wondering, like, what are those? How big is the world of these applications? Because when I've heard mass customization in the past, like I always think of like mass production processes and like, all right, let me change the color and do a quick run of 1,000 of these, next 10,000 pieces are going to be whatever. Some of the lean manufacturing techniques. So is there? I'm trying to reconcile those two different sort of uses of that term.
Yeah, I guess for me, the universe of what could be mass customized is unlimited, but whatever you customize has to support the cost. And right now, almost like nothing does, except for like very specific, usually personal, either teeth or maybe shoes, which is still getting felt out, or maybe jewelry because those are high value items. So yeah, I think like if we get the cost lower, you'll see more things customized.
What's driving the cost right now? Is it like the speed or cost of materials, or what do you guys see?
I think just you don't have the economy of scale, so one off to build it, to have that process in there, the shipping, is going to drive it all up. But yeah, I think fate, shoes make sense for customization, but I really don't see what else I need, and it's nice having maybe customized gifts, but again, the price isn't going to actually justify it as well, so it still seems to be pretty limited to medical, so that's, that industry, it's a lot more important outside of that.
Yeah, I'd say like what we're noticing is audiology is pretty huge. So anything that has to do with like hearing aids, there's always like that traditional method of like making a hearing aid where it's like you pour silicone, it's labor intensive. So instead of doing that, it's like, why can't we just 3D print it, like scan the patient and just print it, and then have something like same day that they can try on. So there's that value there where it's like, for mass customization, a lot of it is done manually, and then where 3D printing comes in is you just cut out that labor cost. Yeah.
But I would also say like there is some labor in 3D printing, and so if we can get rid of the rest of that labor, then like it's an awesome solution for all of these things.
Yeah, agreed.
So it's better than the current, but it still has, you know, automation to be done.
Like most of the costs in 3D printing is actually in the post-processing.
I would say in the labor in general.
Yeah, that's right.
I
Yeah,
assume
no, I
people
agree.
agree.
Yeah. Yeah, it's the post-processing, so like what do you do after the print is finished?
So
The
like
other thing that you have though with 3D printing, you know, there have always been custom businesses and they've been really expensive, right? And because everything is made one-off and there are no good tools. Now we've got some good tools. But we have created a world in which we like to manufacture centrally. So we put the 3D printer in the central location, we still have to do the shipping, and so we have all the extra time, we have all the extra cost of that. When we lived in a world where everything was custom made because we had cobblers, because we didn't have mass produced, we made everything local. So we have to have that world too,
Yeah,
where
just
we stop saying, well, of course I'm gonna make it in China and wait for 6 weeks to get it shipped over here. No, I'm gonna have, I only need one and I'm gonna make it right here, right now. But that's a structural, industry structural change.
So labor is a very interesting point. So, you know, if labor is so expensive, why not just ship tens of thousands of 3D printing machines to China and get it done here? It must be cheaper at some point.
Yeah, so that,
Where exactly is labor needed, and you know what's the approach to make the cost breakdown?
yeah, so like, for example, as Matt was saying, like a lot of dental labs, so there's the dentists, and then they outsource their work to dental labs. So think of dental labs as like a service bureau. So there are quite a few here in the US where it's like they'll do the 3D printing for you and they'll do the post-processing, so like polishing your retainers, aligners, etc. Those dental labs, like I know quite a few large ones that always have counterparts in low-cost labor countries, either in South America or in Asia, to do the post-processing part. So that does currently exist, yeah, from a labor perspective.
But it's probably like a time thing, right? Like you don't want to wait for it to ship, I assume, which is why you do it locally, which is why it costs more.
If you're doing the CAD processing, that's the kind of thing you could easily ship offshore. But what's really more interesting to ask that is, are we moving towards an area where there's more robotics? Because once there's more robotics in that and doing the post-processing, then the labor content becomes less important than the cost of the hardware. And now that changes, so you don't care where you're doing the labor costs, 'cause it's a robot doing it in China and a robot doing it here, it's the same cost.
There's a company in New York called Voodoo Manufacturing, so they basically have just a warehouse of maker bots, and so they have robotic arms that are lifting up the pieces and bringing it in. They're not doing the post-processing yet, but they have been able to, they've beaten us a lot. When someone wants to order, like 30 PLA parts, they can do it really, really reasonable. But that's only if you're happy, because maybe you don't need the post-processing. If you want to just get it out to users, so you have 50 users that are going to beta test your units, then you can live with post-processing. Not everything
Right, and
needs to
there's
happen.
the applications you talked about, like jewelry, where there's almost no post-processing, because you're gonna go out and cast the shape that you want. Then you're gonna go out and burn it out, right? So,
Yeah, well, like even just for testing, if you
Yeah.
have 20 models that you're going to create and use it in different conditions as well, it's fine. You don't have to worry about that. It's done that way.
question on business model. Obviously, you sell printers, you sell materials, and you have a services model. Any success in one versus the other? Which one will survive? Which will be easier? Any particular market that works on for selling machines?
I don't know, I feel like our business model is similar to, let's say, any other like printer company, like HP, where it's like you get the hardware side, but then I think a lot of the profit actually comes from, the recurring revenue comes from the materials, because it's a consumable. Yeah.
Yeah, no, materials definitely historically, whether it's razor blades or 3D printing materials, they tend to be really high profit margin, and I think that's why we're starting to see, at least service bureaus that I've talked to, there's a lot of them that are Stratasys and 3D Systems. They lock their machines down, so you can only use 3D Systems materials or you can only use Stratasys materials, and there's not really, in a lot of cases, there's not really good reason why you'd only want to use their materials. Like, it's not necessarily better than other people's, since it's usually way more expensive. But they lock you into that, and I think a lot of people are starting to get frustrated by that and looking at more open material printers, where you can go to more competitive providers, and so yeah, I think we're starting to see a slow shift towards. Potentially towards open material options, and I guess from our perspective, we're a little bit too early to say we have had success with anything in terms of business model, but we actually are doing parts as a service just to get early quick feedback right now, and potentially materials in the future. But from our perspective, if you sell bulk materials, then you can a lot of people already have 3D printers that would be compatible, and you can get it to a lot of people very quickly if you're doing that. So that's exciting to us, especially since if we have a new exciting material, then we can easily get it out to a lot of people who want it.
So I guess Fictiv, we're really a software service, we don't own any of our own machines, so we're not kind of burdened. We're not trying to make money back on these machines. So we like that it does give us a lot more flexibility into what we can offer. We're not pushing customers to one process or one material as well. But we are giving money back to these machine shops as well that have idle machinery. So our margins are going to be much lower than traditional hardware, but it allows us to scale very quickly as well. If we need to, we can bring on more users, and we can easily get more machine shops into our network as we grow as well. So it's more sustainable, and our investments really on the software. I think the process of ordering parts at the moment is quite hard. There's a lot of barriers, and especially with CNC machining, a lot of machinists, they don't have any customer service reps, or it's just kind of one person machining. So we can provide them business, and we can send parts to them. So that gives us a lot more room to maneuver there as well.
Can you guys talk a little bit about the software side? So I guess this is for Fictiv and maybe for Formlabs. In terms of like the intelligence or feedback, do you have any feedback loops from like how does a part come out of the process, whether it's 3D printing or figuring out what process to use, and then feeding back to improving essentially your software to make that decision for the next part?
Yeah, so from a software side, we have two things. So one is called Preform, so it's a software where you set up your prints. And then the second part to our software is called Dashboard, where you can see a whole history of your prints, take notes on it, and basically have sort of like a feedback loop. And this is like really important. The dashboard is really important when you have a lot of users using one printer. You get to see the whole history and data stack on the usage of that that printer. In terms of like feedback on the software, that typically comes through like support tickets that are like submitted on a website where users are having particular, let's say, trouble or have suggestions on software improvements. And I think like we typically update our software and firmware based on customer support feedback like every 3 weeks or something. So it's like constantly iterating based on customer feedback.
Are the machines, can the machines send data back to you guys as well?
Yeah. If the users opt in to do that, we'll be able to collect their data and then use it for improvement.
Ours is a hybrid, and it's a mix of automation and human as well. So typically when someone uploads a file, they'll use a 3D viewer, and so things that are like thin wall on a 3D printed part will automatically get flagged, and the user will see that that's going to be an issue. For CNC machining and stuff like sharp and turn corners, that will automatically get flagged. But when you want to get a quote, then we have a manufacturing engineer that will actually check that as well. So some of the things that we can automate are just like different setups. We will automatically do threaded hole detection on CNC parts. But that's kind of, a year ago we couldn't do that. Everything was completely checked by an engineer, and so we were able to get this data to see, okay, this is something that's kind of reoccurring. So the things that are like common, then we will automate as much as possible. And then once you have something that has a bit more complexity that kind of falls outside of these parameters, then we also have a manufacturing engineer that will check every single quote to make sure that it's correct as well. But then on the side where when we send to vendors, it's the same thing. It started off, it was quite manual, and over time we got to learn what vendors were really good at what type of parts and what type of material and what sizes as well. And so now we know that straight away, like, this is a great part for Brian, and it just goes directly, they have a chance to accept or reject. But on the actual scheduling side, the vendors, they still have to they see the price, to see are they going to take it or not. So that is quite manual, but the actual quoting part is, for simple CNC parts, completely automated, and then once you get a little bit more complex 3D printing, it's really simple. There's very few things that fall out of that parameter that we aren't able to automatically recognize as well.
And then essentially able to do more complex parts over time.
Yeah, so the more we're all the time, we have 3 computational geometry engineers that are constantly looking to see how can they do auto quoting over time and make the whole process efficient. Yeah.
So I would just comment on the closed loop feedback part of that. If whether it's to some extent CNC machines already have this, they have the closed loop feedback of maybe torque sensors or other things, but honestly it's really hard to do, not before the process, but after the process. It's really hard to get feedback unless you have, say, a 3D scanner built in and it knows what's going on, and maybe, depending on the part, some other things as well. But that adds cost, and so I think we'll see machines for high value parts that will have that in the next 5 years. And they'll, maybe we'll have a metal printer that has an X-ray machine built in, so just every time it just checks, I don't know. But you really need that closed loop feedback to really know for sure, which I think was maybe part of your question.
Yeah, I appreciate that. That's very interesting. Yeah, I was curious if, to what degree does the loop get closed, or thoughts of how to do that, I guess.
Yeah, not much.
Yeah, I guess on that, we have to ask customers a lot of questions as well. So is this going to be a mating part? What should the orientation of it? What are you trying to do with this part as well? We do 2D engineering drawings as well. So tolerances are quite hard to specify as well. And so it's a back and forth as well. So we will get we would get pushback from, we'd say, hey, this corner is just really, really hard to machine, or hard to, we're going to have to put in a fillet here as well. And, then the engineer will come back and be like, absolutely critical. And so it's like, there's a conversation that then kind of happens, and it's like, all right, well, maybe if you did it here and then you come in with this tool, then maybe we can make it happen. Especially with more complex machining, there does have to be a bit of give and take as well.
Yeah.
Like, hey, this is what you need to do once you make this available manufacturer.
Okay, any other questions? Okay, we used up all the time, so thank you all panelists, thank you all for coming, and you're welcome to stick around. We'll find this on here for question and answers.
Yeah, thanks for coming, everyone.
Thanks, guys.